I am Prabhakar. Today we are going to study motion in one dimension and some applications of constant acceleration case of a particle. The equations of motions for constant accelerations, as we have seen earlier, are the variation in velocity as v is equal to v0, that is initial velocity, plus at, where a is the constant acceleration. That is equation number 1. Equation number 2 is about coordinate x is equal to x naught plus v 0 t plus half a t squared, where the variation in the position is as a function of time, position is indicated by x. The third equation gives you the velocity as a function of displacement, that is v squared is equal to v naught squared plus 2a into x minus x naught. Now, equation 3 we have got it by combining equation 2, 1 and 2 by eliminating t. Now, look at these graphs which give you the representation of equation 1 and 2. The first graph, v versus t, the slope of this graph gives you the acceleration. Equation number 2 is represented in graph number 2, where position has been plotted against time. The initial position at t is equal to 0 is marked x 0, and the variation of position with time is a parabolic curve, because equation x is equal to x naught plus v 0 t plus half a t squared gives you the equation of a parabola. Now, the slope to this curve at t is equal to 0, if you draw, then you get the slope as v 0, that is slope of x versus t gives you the velocity, and at t is equal to 0 it gives you the velocity at times t is equal to 0, that is the initial velocity. At any time when the object is at say position x, at that point if you find the slope, then that gives you the velocity at that instant of time. Now, let us look at these graphs that are being presented here. Now, the question is, all these three graphs are variation of position with time. Graph number 1 shows a concave, the other one shows a convex, the other one shows a straight variation of position with respect to time. What can you say about the acceleration in these three cases? Is it positive, negative or 0? Now, how do we approach it? Now, let us find out the velocities at different intervals of time. Let us take A, B and C as the point and try to find out the velocity at these instants of time and how velocity changes with time as time increases. The slope of this graph at point A is something like this, which has a negative slope, means the velocity is negative. At this point B, it has a positive slope and a small slope. At point C, it has a positive slope and a large value. Now, as time goes on increasing, the velocity at point A, B and C goes on increasing. So, the acceleration is positive acceleration. Now, we can approach the same and try to find out the answer, what happens in x versus t for graph number 2, and graph number 3 should obviously say that it is the slope of this line is constant. So, the acceleration is 0. When x versus t graph is a linear graph, acceleration is constant and it is 0. In this case, the point A, B and C, you can mark it and try to see whether it is velocity change, is it a positive thing or a negative thing. You will get the answer. Thank you. Look at the position time graphs of objects A and B in three cases. In first case, A and B variation of position with respect to time are parallel. What do you conclude from this? In graph number 2, there is an intersection and B and A intersect at this point. What can you say about the velocity? Which has a greater velocity? Now, in 3, the displacement, the x versus time graph of B increases with time and here it is decreasing with time. Notice that the slope of B is positive, slope of A is negative. So, what does it mean? Here we are given a situation where an object is being thrown with a velocity of 12 meters per second, and the location is 32 meters above the ground level. The question is the time taken for this object to reach the ground. Second, velocity when it reaches the ground. How do we solve? Find time taken to reach the ground. You can use any of these equations. V equals u plus at, or S is equal to ut plus half at squared, where I have written u for V0. Now, how do we solve for the time? Given that the acceleration is downward, that is 10 meter per second squared, the object has a velocity V0 as 12 meter per second. When does it reach the ground? It reaches the ground after going up and coming back. Let us assume that the time taken be t. Now, the displacement, that is from this position to which comes downward, goes up and comes downward. If you take upward direction as positive, now finally the displacement is to be x minus x naught if the initial position is x 0 and this is x, and that has been given as 32 meters, and if I take positive direction as upward, x minus x naught happens to be 32 meters and with a negative sign. So, minus 32 meters must be equal to V naught t. V naught is 12 meter per second plus 12 meter per second, because that is in the upward direction, time we do not know, plus half acceleration. Acceleration is in the downward direction. So, we will write it as minus 10 meter per second squared and t squared. The solution of this equation, which is a quadratic equation, will have two answers. Use the knowledge of algebra which you have learned and solve for t, and then you have two solutions for t as t is equal to 4 seconds and t is equal to minus 1.6 seconds. Which of these will you choose and why? Are these possible answers? For the time being, say 4 seconds is fine, let us take it. The reason for rejecting minus 1.6 seconds should be made very clear. Why? You say time cannot be negative. Now, please note t is equal to 0 is what we have chosen. So, time before possibly it was here. Let us take t is equal to 4 seconds, and t is equal to minus 1.6 seconds can also be the right answer given certain other conditions. That is 1.6 seconds before it started, it was here. Now, use t is equal to 4.4 seconds and you can work out the velocity using the equation v is equal to v naught plus at. Now, you know v naught is 12 meter per second, g is minus 10 meter per second square, and time is 4 seconds. This will have minus 28 meters per second. What is the meaning of this? V is equal to minus 28 meters per second. You can understand it because initial velocity was considered positive, it is in the upward direction. When the object reaches the ground, the velocity will be in the downward direction. Look at these graphs, graphs A, B and C. In graph A, you have position variation with time represented by a line parallel to the x axis. Is it possible? What does it mean? It means at any given time, position goes on changing. At any time, an object can have one position in this universe. So, is it possible? Think about it. The same kind of a thing, look at the graph number 2, where the variation of velocity as a function of time and it is parallel to the v axis. It means at a given time, the velocity goes on changing. Is it possible? Look at graph number 3, C, where the variation of x with time, that is the variation of position coordinate with time, follows a circular path. Is it possible for any object to have this kind of a thing? Look at any time, it means either it can have x1 as he indicated here, or it can also be there at x2. An object, can it be there at two places at a given time? Having studied the motion of objects with constant acceleration in one dimension, the next few classes we will see how the variation of displacement or position of a particle in space, that is in 2 and 3 dimensions.